Hello my friends, welcome to your channel. This is World of the Technology Descriptions. My name is Maziar and I am a mechanical designer. On this video I want to show you how I made a variable ratio gearbox with FDM 3D printer. If you desire to see more, please subscribe my channel, like this video and click on the bell. This work encouraged me to share more with you. Thanks for your watching and I appreciate you. Let's go to see that. This is the first step. On this section, I consider an approximate dimension for my gearbox, and based on that, I make accurate calculation for my gears. Fortunately, I can obtain main CAD file of the gears based on accurate calculation, and I prepare all of the segments on this section. So I want to assemble all of them together. I have a shell, output cover, main chassis, electromotor chassis, electromotor flange, input coupling, output coupling, a slider, gears, a slider guide. Here I have a slider guide. Furthermore, gears, a slider, input shaft and output shaft. I separate some of the segments, such as a middle shaft or electromotor chassis, because I avoid to make support part on printing procedure. I have input coupling. This coupling makes a connection between electromotor and input shaft, and similar to flexible coupling, but I don't use flexible segments between the teeth. I consider a chassis for electromotor because this electromotor is too heavy and has more vibration. I avoid to insert this vibration to input shaft. I embed this electromotor on this chassis to transfer its weight and vibration to main chassis. If you approve this video and tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. I assemble all of the segments together, and I want to explain all of the procedure on this gearbox. This electromotor is rotating constantly on one side, and I use this coupling to transfer electromotor rotation to input shaft. Input shaft is rotating constantly, and it is connected to this gear. These gears are double row helical gear because helical gear make two elements of the force align the main shaft and between the gears, and this stage make more force along output shaft, I prefer to choose double row helical gear for the first stage. This is middle shaft, consists of 4 gears. This one, this one, this one, and this one. Here I have 3 ratio to transfer to output shaft. First ratio is between this gear, second is between this gear, and I can connect input shaft to output shaft directly. This is the third ratio. I can use this slider. When I move this slider to right side or left side, I can make a connection between this gear or this gear with output shaft. And furthermore, this is true for this slider. When I move this slider to right side, I can make a connection between this slider and input shaft and transfer electromotor rotation to output shaft directly. All of these gears are rotating freely on output shaft. On this section, I want to show you that how I can make a reverse rotation for output flange. This gear is constantly rotating on one direction. I stick this gear to middle shaft and I use middle gear to reverse direction of the rotation for output shaft. This gear is rotating freely on output shaft, and when I move this slider to right side, I involve these teeth together to make a connection. I use a slider guide on this section and on this section and on this section to move a slider. And I use this handle to move a slider guide. At this moment, I want to say that I avoid to focus on all of the principle on my design. For example, I avoid to use bearing because I want to make a simple type of the gearbox. It goes without saying that I must use an important middle segments between a slider and gears, especially for this stage. These coupling tend to rotate on one direction constantly, and if I want to make a reverse direction for this one, I must connect this slider with this gear. This gear constantly is rotating on one direction, and this slider is rotating on other direction. So I must synchronize rotation of the gears and a slider together. So most of the designers use a middle segments to synchronize their rotation, but I avoid to use that. When I rotate input gear, middle gear is rotating constantly, and middle gear is connected to this gear, and this one. So this gear, this one, and this one are rotating constantly. Here I have a ratio, here I have another ratio, and this section I have another ratio, and I can make a reverse ratio with these gears. You can see this gear, this one, and this one are rotating on output shaft freely. If I make a connection between output shaft with every these gear, I can transfer ratio to output shaft, and I can reverse direction of the rotation for output shaft with this mechanism. This is the second step. On this section, I convert CAD file to STL file and bring on this software to make G-code file for a 3D printer. First of all, I want to point out about the main principle. For this segment, you can see I print this segment layer by layer from my table to upper layer. I have a ceiling part. This is overhang layer. When I want to print ceiling part of a segment, I must make support part under ceiling part and print overhang layer. This is a problem and make weak texture on my segments. So at this moment I try to find a solution. I have a simple solution. I can separate this segment to two parts and put everyone on the table. This is electromotor flange. On some of the segments I have no way and I must bring some of the part on support part. For example, like this. Green part is the support part. And you can compare that which strategy need more support part. I choose this one. Blue layer is a ceiling part. And when I want to print this layer, I must make support part under the ceiling part and print remaining part of the segments like this, layer by layer. I do this work for all of my segments. I bring all of them part by part here and make G-code file and produce with 3D printer. So let's go to see some of the moments of my printing. If you approve this video and tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. This is the third step. On this section, I bring all of the segments and I made them based on CAD file with FDM 3D printer. Here I have gears, input shaft, middle shaft, output shaft, spacer, output cover, output coupling, spring, sliders, main chassis, slider guide, electromotor, electromotor chassis, electromotor flange, and coupling. Coupling make connection between electromotor and input shaft, like this. Because the electromotor is too heavy and have more vibration, I make a chassis for electromotor to bear its weight and vibration and transfer its vibration to main chassis. This is the main shell. This shell consists of basement and a slider guide. And here I have a handle. I can move a slider guide to left side or right side, like this. At this section, I want to assemble output shaft with its segments. Here I have a gear. This gear can rotate freely on the output shaft. And when I want to make a connection between this gear and output shaft, I use a slider to make a connection between output shaft and this gear. Here I have a spacer. This spacer has a pin. I use this pin to connect this spacer on output shaft. I have a slider. This slider has teeth, and I can make a connection between this slider and this spacer. When I want to make a connection between the slider and the gears, I move the slider to right side to make a connection. You can see I hook this gear to a slider and output shaft. Here I have another slider to make a connection between input shaft and output shaft to transfer rotation of the electromotor to output shaft directly. This slider has a teeth, and inside this segment I have a teeth. And you can see input shaft is rotating freely, and when I move a slider, I can make a connection between input shaft and output shaft. This is middle shaft, and all of them are connected together. These gears are helical gear and make a force along the output shaft. But I choose double row helical gear for input shaft and this gear to avoid more force along the shaft. At this section, I want to assemble the shafts inside the shell. Let me to do it. This is output cover, and I want to assemble this cover on the main shell. I put all of the segments together. I rotate input shaft, and you can see how all of the gears are rotating freely. I have two ratios between this gear and this gear. When I want to transfer this ratio, I use a slider to hook this gear to output shaft. And when I want to transfer the ratio of these gears, I use this slider to make a connection between this gear and output shaft. Most of the designers use a middle segment to avoid making a connection immediately, but I don't use it. I have another ratio. I can make a connection between input shaft and output shaft and transfer rotation of the electromotor to output shaft directly. Output shaft is rotating freely. You can see when I rotate output shaft, a slider and a slider are rotating freely. I want to check it. Let me to assemble electromotor on the main shell and assemble all of them on the main chassis. On the outer part of the gearbox, I want to assemble reverse section. This section consists of 3 gears to reverse rotation of the output shaft, because constantly electromotor is rotating on one direction and all of the gears are rotating on one direction. So if I want to change output shaft rotating direction, I must make a reverse connection between middle shaft and output shaft. Here I have a gear. This gear is connected on middle shaft. I put this gear on output shaft and use a middle gear to reverse rotation of the output shaft. I have output coupling. This gear is rotating freely on output coupling, and I put a slider on output coupling to make a connection between this gear and output coupling. When I want to reverse rotation of the output shaft, this is a slider guide and I assemble it and put all of this package on output shaft. Here I have a spring to bring back a slider. Output flange is connected on output shaft, and furthermore this slider is connected on output shaft. This slider and this slider are connecting on output shaft. Here I have a reverse mechanism. When I move this slider to left side, I make a connection between this gear and output shaft. Here I have a big problem. Electromotor constantly is rotating on one direction, and furthermore middle shaft is rotating on one direction. But I want to make a reverse direction for output shaft. So I must make a connection between this gear and output shaft. And I have a problem. Because this gear is rotating on one direction and output coupling is rotating on other direction. So I need a middle segment to synchronize both of them together. But I don't use this solution. At this section I want to show you when I use handle how I make a connection between this gear and output shaft. At this section I want to test it. So I plug electricity to electromotor to show you how this is working. When I start electromotor, input shaft and middle shaft are rotating. I have two ratios between this gear and this gear, and I can make a connection between output shaft with this gear for one ratio and with this gear for another ratio. And I can make a connection between output shaft and electromotor to transfer electromotor rotation to output shaft directly. See this slider and you can determine that when all of the gears are rotating freely on the output shaft can't rotate. And when I make a connection, how output shaft is rotating. So I put this handle on this gap and use its moving to right and left to move a slider. Here I want to show you how I can make a reverse direction for output shaft. With this mechanism, I put this handle on this gap and make a connection between this gear and output flange. If you approve this video and tend to see more, please subscribe my channel, like this video and click on the bell. Thanks for your watching. will return very soon. If you approve this video and tend to see more, please subscribe my channel, like this video and click on the bell. This work encourages me to share more video and I will make more interesting video like this. Thanks for your watching.